We've got Omar first.
Thank you, Jasper. So this is going to be so quick. This is Omar from Edraak. We do Arabic MOOCs in a nutshell. I'm going to talk to you today about how did we localize the math in our platform. So this is going to be more about the localized math rather than the platform, but the context is still within the edX platform. So here you see text, right? I'm sure most of you can't read that. This is the same for our students when they see that one. Semantics-wise, they're perfectly the same, but in terms of the syntax, you can see the difference. So why is this? I'm sure you know that math education is important, and the math scripts have been found as early as 4,000 years old. So despite the changes that have happened to the language now, English is the most, or let's say European scripts are the most common scripts found. However, students in the 22 Arabic countries are still K-12 learning the equations in Arabic, just like the one you saw. So how about the edX platform? So we're lucky to have math stacks already set up on the edX platform. So if anyone wants to display a beautiful equation, he would write the LaTeX for it, and it just shows it's beautiful and it works. What about Arabic? Oops, no support. Math stacks only works on the European. So what's the alternatives? Some of us want to use Microsoft Word or like this one, handwritten and scanned, but it doesn't work. It's not really, maintainable. It's a mess. So that's why it took us a lot of time, but I'm going to go short on this. We developed an extension for MathJax that accepts the same LaTeX input and displays it in Arabic. It does a lot of things, including, it translates variables, function names, of course, the RTL. As you can see, the equal sign here, it's flipped on here. So this is the first part, the RTL, and the second part that every single symbol is almost translated. So what does the results look like? Of course, it has to be better than the handwritten one, right? So this is the English one, and this is the Arabic one. So this one is a screenshot from the actual renderer on the web. So this is not a photoshopped one or something like that. This uses the same text syntax that you can find that you can use in any MathJax or LaTeX environment. So this is a slightly more complicated equation that I want just to test out the system that we did. So it's a meaningless equation as far as I can tell, but here you can see the LaTeX that the author writes. And typically the author is English literate, so that's not a problem. But we're more addressing the learner side of the problem. So and that's it for what have been done. And next steps. The current implementation is it's an extension, so we are planning to put it within the MathJax v3. Of course, the MathJax team has been very generous to review it for us and the extension and to suggest this implementation. The font is not really good. We need a better math font and perhaps support more languages like Urdu, Persian, and so on. There are multiple languages that could benefit from this one. I have an ambition that I could contribute to the Arabic version of Wikipedia, but that's a long way. Here are some links. This is the code. If someone wants to discuss it, I'm going to be available, so please feel free to reach me out. There is a math course that we use at Edraak, which uses this extension extensively. And as a bonus, I would like to invite you to see my Git OSPR repo. If anyone does a open source PRs for the edX platform, this might be really helpful. And these are our current edX platform that runs Jenkins like the full testing. This is a bonus. This is not related to my question. And thank you.
Hello, everybody. I'm Leonardo Salom from the Universitat Politecnica de Valencia. I'm here to talk about JavaScript tools to enhance language MOOCs. we have a problem to fix. That is, if you remember the old drag and drop problem, it has a problem with the mobile version of the platform that it has no touch controls. We thought about making an XBlock to fix this or improve the code, but we thought we have no time because the course was already running. So we thought that we can just inject JavaScript onto edX to fix the problem. The idea was quite simple because we just wanted to fix the touch input in this part of the code. Quite quick and dirty, inject the JavaScript, add the functionality, and go. And it worked. So after that, we thought on some quality of life change, because our students wanted to repeat the problems to do tests, and afterwards repeat and repeat. So this way they can approve the real exam. So if you work with a platform, you have a reset button downside, but when you answer correctly, the reset button disappears. It was a problem because we wanted it to be reusable by everybody so they can retrain, and what we did is the same. Inject that JavaScript into edX, and yeah, the reset button keep there even if the problem was already correctly done. So what's next? Actually, this is kind of a problem because when you have a problem set, you have a set of problems. Every problem has his own reset button, and as you know, it can be tedious. Oh, I want to repeat the test. Reset, reset, reset. It's not comfortable. So more injection of JavaScript, we created a reset all button. So instead of resetting every button on his own, the students just press once, reset all the exam. We keep doing this because we keep comfortable with the way the platform behaves, and my boss liked the quick work. So after this, we decided to add functionality. So when you are on a language course, you can have a problem because the speaking or the listening, si os hablo en español, puede pareceros muy rápido, because the tempo maybe it's not good for you to listening. And we made a quick tool that on there we have an HTML5 audio tool, and we added a slide with JavaScript that controls the tempo of the audio file. So this way, it was kind of easy for the students, make it slower. It controls tempo and pitch, so it doesn't sound weird. And this way, the students could listen slowly how it pronounces and make it easier the learning. So this worked well. The students were happy, and we tried a little bit more. This time, we did a pronunciation exercise. Our whole idea was the students listen to some recording. Afterwards, they record themselves and listen to themselves. This is nice because I don't listen to myself the same way that I listen a recording of myself. Maybe I think I'm pronouncing correctly, but obviously not. So this was nice. So that's it. If you have any question. Yeah, without that, since this is kind of dirty, we are providing a blog with all these little sketches. So I'll post in the forums or the community, so you can access to it. Yeah, you're welcome.
Hi, my name is Pierre Mailhot. I'm from the Université de Montréal, and we'll talk about building a multilingual platform. First, a context. EDUlib is the only Francophone education consortium in North America. It's a joint venture between Université de Montréal and two of its associated schools, which are the Business School, HEC Montréal, and the Engineering School, Politecnica Montréal. And we still have more partners coming up that will be running courses on our platform. The problem is that when we decided to run EDUlib first, we only wanted to have courses in French. So the platform was unilingual in French. Running a unilingual platform is easy because everything is only in one language. But if you have problems, for example, text that is not translated, you simply hard-code it in your fork or in the code, and then it gets in your language automatically. English is easy, for example, because you have nothing to do. But if you want to have French, then you run into examples where you need to use transifex for the translations, you need to share translation between FR and FR Canadian because there are differences in some technical terms. There are problems with Unicode, for example, because if you have a piece of text that would have accented characters, then sometimes the code doesn't support Unicode. So I included a lot of PRs over the years. So there was, and then you have to decide, do you fix it only in your fork or do you push it again to the main code? Then you have to translate informational page, like the about page, the FAQ, the honor code, and all these questions. So you have to have a page in English and a page in French. Oh, XBlocks. That has been one of my major problems. For example, sometimes there is supposed to be some code to internationalize XBlocks. It doesn't work. For example, for UBCPI, we had to clone the fork, create a French branch and an English branch, and then that means that depending on the course, you use either the French or the English version. But then you have to modify the code extensively because you need to have the differentiation so that the XBlocks are unique. Then you need to rework everything. So that really does work well in some cases, but in others, like drag and drop v2 and active table, it didn't work at all. Certificates. We are still using PDF certificates. And in the code, if you use the PDF certificate, some of the terms are hard-coded. So we needed to replace the places where the code, the English nomenclature was, so that we had to create PDF templates that were language agnostic, so that depending on the course, we would add the parts in French or the parts in English. Templates. That's another issue, because some of the templates, you've got the original text in English. But if you want to support English and French, then you might need to rewrite the English templates. And if you rewrite the English templates, then there is no longer any translation in transifex or in the Django or Django script, JavaScript files. So at that point, you have to create your own translation and add them into your files and then recompile the messages and everything. Scientific notation and dates. In Canada, at one point, we switched from the English system to the metric system. So there's always the problem between the comma and the period. And one of our first courses was an engineering courses. And the teachers, the first time they saw it, they said, oh, but we wanted to use the comma. No, you can't. Browser avoids profile language. For example, we want the users to have a great experience in French and English. So we have to make a provision so that they can access the site in their own language first through the browser, and then they go through the user preferences. But that has some very interesting consequences at one point, because sometimes you will end up with a page in both English and French. We also translated the powered by edX logo so that we would have it in French, but then we ended up with a new problem. How do you switch it to French to English whenever the user is? And at one point, we had discussed it yesterday, maybe we could have a buff discussing things about internationalization. And we're always available to discuss any topics we may have touched upon in that presentation or not. And these are our contacts and questions. Thank you.
Hi, everybody. Thanks for coming to this lightning talk. My name is Aneesha. I work at UQX. This talk is entitled edX, XBlock versus LTI. So at UQX, we make a lot of MOOCs. We have a catalog of 30 MOOCs, and we continuously run these MOOCs in either self-paced or paced mode. We're a large team. We're about 15 people. We've got project managers, learning designers, video producers, and we have a dev team of 3. So as you can imagine, we make a lot of learning and teaching tools for our courses. We try to make them interactive and engaging. This is just an example of a tool where we teach a student how to participate in an emissions trading scheme. This tool is embedded in our Carbon 101X course. So a tool like this is really very domain specific. So it'll only ever be used in one course. And we use LTI to do this. However, we also make tools that can be applied to any number of courses. So this particular tool here is a ranking poll, and the way it works is students are given some things to review. So in this case, it's applicants for a job interview. They can rank these applicants and then also see how other students in the class have ranked these applicants. So we've used this in our psychology course and also in our carbon course, where what students were ranking were projects that they wanted to invest in. We also have a reflective journal, which is reused in a couple of our courses. So the thing with the last two examples that I've shown you here is that they're reusable, and we're doing them all as LTIs. Now the reason we do them as LTIs is because it's hard to get an XBlock deployed really fast in time for our MOOC release dates on edX.org. What LTIs allow us to do is to add things when we want to, and also fix them when we want to. However, there's a large community with supporting XBlocks, and also a large community deploying Open edX installations. And we believe some of our tools can really benefit this community. So the solution really is, I've been trying to think of a solution to this problem, and it's to actually try to combine XBlocks with LTIs. So if we can take an XBlock, put it in an LTI, and then plug that into edX.org, we still get the functionality of the XBlock, we get the functionality of an LTI, and we also can deploy our XBlocks to any other LMS. So on campus, we use Blackboard. So as you can imagine, we not only want our tools to be used on edX, we also want them to be used on Blackboard. So the technical solution to this problem that I've been working on actually uses a Django LTI tool provider. I looked around for a lot of them. The one I've settled on actually is really tightly integrated with Django. So it's got a auth backend, it's got middleware, it lets us have decorators to define the role to access our views, and we can get the LTI data straight from the request object. And I've taken the XBlock dev workbench runtime and embedded it inside the LTI container. What does that look like? The XBlock will display in an LTI. We actually have an edit XBlock, which gives us the ability to give a name, a description, which resource ID is that coming from the LMS. But we can also select different XBlocks and then edit the XML. So you can think of it as any XBlock I've installed, I can embed anywhere else, and it's very instance-based. So lots of polls, lots of reflective journals all over the course you can use with this tool. Going forward, really the things are improve the state management by using Postgres and JSON field, because at the moment it's stored in a text field inside the workbench. Django auth LTI doesn't have grade sending. It's built really wonderfully, but there's just one thing missing. I've also got to figure out how to get the whether the answer is correct or incorrect from the XBlock, and can I get a UI and better CSS styling inside my own project? And that's really it.
Hi guys, I'm Eugeny Kolpakov. I'm working at Opencraft, and I'm going to tell you about edX cookiecutter templates. So this is, our logo and my contact information. Yeah, so this is how I usually feel when we got to, start new project from scratch, because we need all those developer tools like version control and build automation and continuous integration and tests and style checkers and so on. And the thing why I'm feeling like that is because all of that tools are basically a decision to make and some configuration to write. And I'm not even talking about DevOps stuff like Docker and Ansible and stuff. So, problem. Development tools require a lot of configuration up front and a lot of decisions up front, and it's tedious and ungrateful task. Can we do better? So, since I'm talking about that, there is a solution. The solution is named software scaffolding. So you actually, if you've done some development on Django, you actually met that before, because Django admin start project is exactly what it is. It scaffolds your new project, and there's a command line flag -- template that allows you to specify your own template and scaffold the project with your stuff. So, but really it is tied to Django, and people went on and created a lot more true stuff, software scaffolders like listed here. So I'm gonna talk about cookiecutter in this talk. So basically, cookiecutter is a Python scaffolder tool written in Python and mostly for Python. It is language agnostic, so people doing scaffolding for other languages like Scala, Haskell, PHP, and whatever. But mostly it is popular within Python community. So, I don't know, does it work? Yeah, so usually cookiecutter template look like this. So there's a cookiecutter repo name in double curly braces and cookiecutter JSON. I don't know if you guys can see it, but I've just told that. So cookiecutter repo name is just a Jinja2 template in a file system of Jinja2 templates, and cookiecutter JSON specifies questions you need to know. Cookiecutter will ask you. So this is how typical cookiecutter session look like. I'll give just important stuff is you run cookiecutter here, you install it, run cookiecutter on either local file system or GitHub repository. It asks you some, a list of questions, and it scaffolds your project. So edX went on and created 3 different cookiecutter templates. The first one is Django IDA template. IDA stands for Independently Deployed Application, if you haven't crossed that acronym yet. So I believe you can read that, but the most important stuff is pep and pylint config, Travis integration, and Sphinx. The next one is Django application template. So it is a little bit more richer because it started roughly at where IDA was, but we used that template to scaffold edX enterprise project, and we shared back some lessons learned. So this is mostly the same stuff. Important additions is adding test infrastructure, code coverage, and GitHub integration. So whenever you submit a pull request on GitHub, it starts with a certain template. So you don't have to, went to other previous GitHub pull requests and copy it. And the last one I'm going to talk about in, a minute, XBlock template. So basically this template is what I used for my workshop 2 days ago. I hoped it would be in the reverse order, so I'm going to do a lightning talk and then invite everyone to the workshop, but it didn't happen. So this one is a little bit less rich than other ones, so there are no code style checkers and static analysis tools and so on, but it's very useful still because it contains setup.py, which is really hard to figure out on your own, and XBlock project layout. That's it. Thank you very much.
Hello, everyone. My name is Miguel, and I don't have a very ambitious talk. I'm just trying to show you how you can deploy separate, independent applications on OpenEdX that take advantage of the edX user accounts. So it's interesting because we want to develop many kinds of new dashboards, new kinds of websites that still don't ask the users to create an account or log in again. If you've used Insights or e-commerce, for example, you notice that they don't ask you to register again. They pull your data right from OpenEdX as expected. So this is great. This is part of edX's plans. If you've noticed lately and for a long time, many of their new components have been deployed independently of edX/edX platform. So e-commerce and Insights are two examples, but this is happening more and more. And this is great, right? What we're going to do is we're going to see how we can extend this for our own. So aside from Insights and e-commerce, a couple of other use cases would be customized administrator dashboards, if not instructor dashboards. And there are always new ideas. So for example, an instructor news feed as to what has been happening in each course, right? Who are the most active students? What are the new answers to the problems, etc. Insights, I mean, just so you know, this is what I mean. It's a separate website with a login feature, as you can see on the top, but that login is against edX platform. So in short, how does this work? Basically, in order to get, achieve single sign-on, we want to use edX platform's data. We want to reference it. We don't want to copy it. Obviously, Insights doesn't have a copied database of accounts. That wouldn't make any sense. And we want to achieve single sign-on and single sign-out. How does this work? Well, pretty much OAuth, right? So you have a provider, which is edX platform, and then you have a number of clients, of which Insights and e-commerce are two examples, but again, there are many more. Just simple OAuth, you go on the provider, you register a client for which you get a client ID and a client secret, and once that client has those credentials, you can go back to edX and say, edX, here are the credentials you gave me, give me an access token. And that access token is what allows it to request and post other stuff. Obviously, on OpenEdX, we have the admin dashboard through which we can add, OAuth clients. If you've done the mobile apps or Insights, you see that this is, I'm sure you've seen this before. So there's something else that has to happen because OAuth doesn't really tell you who the user is, right? If we just stick with OAuth, then Insights or whichever other separate website is not going to know who is making these requests, right? OAuth, out of the box, as in client ID and client secret in exchange for an access token, is great because it gives you that data, but the edX platform would have no idea who is requesting it. By the way, the access token, as part of OAuth, doesn't really tell you this information either, and the client has no way of deciphering this. The OAuth standard goes more into this, but it's, the solution here is that we have to supplement OAuth with something else, right? Something that takes the standard OAuth flow and adds in these user credentials. So user credentials, as well as maybe some information pertaining to the expiration of the access tokens. OpenID Connect is this external component, and this is what edX uses, right? So OpenID Connect essentially builds on top of OAuth. It takes their client IDs, their secrets, and access tokens, and just adds a user identifier, right? That user identifier can carry a lot of information about the user, but that's essentially what it is. Great. How does edX do this? Well, they have another repository called Auth Backends. It's right on GitHub, and this is where they have defined an additional authentication service, which, as you know, is great for Django, right? Django allows you to specify additional authentication services, relatively easily. You define a class, you define a couple of methods, and you import it into your client. So how does that work? Well, first of all, you have to install it, but edX has it in the pip directory, so that's pretty nice. Pip install edX auth backends. If not, you could directly install it from the repository. But once you've installed it, you add it to the authentication backends in Django settings. You have to define a few more settings, and this is because of how this works with Python social auth. So you have to define maybe what was that OAuth secret, what was that OAuth client ID, maybe what's that URL. Oh, sorry, I'll go very quick. So then you also have to define a couple of URLs, right, for login and for logout. And you know, the main points are this. This is pretty simple, but just so you know that there is another repository called Auth Backends, which you can use right out of the box to build any kind of additional dashboard or separate website that you still want to use to take advantage of edX's data. There's an asterisk on OpenID Connect because there are a couple of ways to do it, and OpenID Connect is not the only way to supplement OAuth with those user credentials, but this is how it's currently being done. So that is all. Thank you.